Hello friends, good evening. Welcome back to Oil and Gas Data Analytics program. So here we are discussing different factors that are related to oil and gas data analytics. So day one, we have started with applications. So we have looked into different applications of data analytics. Okay, data analytics in oil and gas industry. Day two, we have looked into the CRISP ML methodology. CRISP ML methodology that comes with quality assurance. And on day three, we have looked into different EDA, okay, exploratory data analysis and data pre-processing techniques. So these are common for any data. It could be a oil and gas analytics, or it could be any data. EDA and CRISP ML methodology are common. Okay, we have to start with CRISP ML methodology. Okay, so after that, we will be looking into EDA part and data pre-processing. So on the day four, we have looked into unsupervised model. So we have something unsupervised model here. In case of unsupervised model, we have seen k-means clustering. So in case of k-means clustering, we have looked into, we have tried to create, okay, we have tried to look into different companies data, which includes the oil price and the share price. So we have tried to create clusters based on the similarities between oil price and share price for a timeline of like approximately like 20 years. So what is happening? What is the trend that is happening in this data? So when it comes to unsupervised data, it is unlabeled data. Okay. So on the day 5, we have looked into KNN, K nearest neighbor. It is a classification technique. So we can do the regression problems also, but when we are saying classification problem, we have seen that we worked on lithology. Okay, the stones, the different stone material that will be available in the oil fields. So based on that, we had a research data. That research data we have worked on, and we have tried to classify. Okay, we have a categorical data here. If we have a categorical data and we have tried to classify. Okay, so this we have worked on. So today we are going to look into one more supervised learning method, that is decision tree classification. Okay. So this method is also mostly used in categorical. So when my output data, okay, when my output data is categorical, okay, either it is a binomial data or multinomial data. It could be a binary class or multi. So these are few things that we have looked in the past sessions that we had. Today we are looking into decision tree. So we are trying to so we look into what is decision tree is, what is this model, okay, and how we are going to build this model. Okay, on what basis we are going to build this model, and we have some algorithm that is known as greedy algorithm. So we are going to look into greedy algorithm also. So here, how to build a best decision tree. That is also one factor we are going to look into. So how we are going to get these values, and based on these values, right? So we have to do some quantification. So we are going to take the information gain, okay, and we'll be looking into business use case. Okay. So that is something related to oil and gas industry. Okay. So let's look into what is decision tree. So we have gone through many flow charts, right? So flow charts are something related to some program or some data, we will be having different flowcharts. So in flowcharts, we'll be looking into different connections. Okay. After this process, we'll have this process at the end. We'll be having some. This is the product. Okay. Maybe this is the solution that we are looking into. And to reach that solution, we'll be having a flowchart. So when we look into the data, when we say the decision tree, it is also a type of flowchart. Okay. So how we are going to take these values? How does this structure occurs? So here we are going to look into three parts. Okay. So we have root node, we have stem node, and we have leaf node. So it's a tree-like structure, but in a reverse order. Right? So it contains a root, stem, and leaf. It's a tree-like structure, but it is in a reverse order. So what we have here? So in a decision tree, the non-terminal nodes, okay, the non-terminal nodes and the terminal nodes are different here. So what are non-terminal nodes? So the terminal node will be leaf here, and the non-terminal nodes are stems here. Okay. So non-terminal nodes are used to make the local decisions based on the local information they possess. So when I'm saying about non-terminal nodes, okay, when I'm saying about it, these are okay here in this picture, we can clearly see that the nodes that are represented in blue color, these are nothing but the non-terminal nodes, and here I am going to have a decision here. Either it could be yes or it could be no. Okay. So here I am going to have a decision. Either it could be yes or no. Okay. The same way, these are known as decision nodes. That means here we'll be having stem. Okay. This is nothing but the stem node. Okay. We have a root node, we have a stem node, and we have a leaf. So the whole decision tree is divided into three different parts. So terminal nodes make final decision. So it could be any decision. The final decision will be coming from the leaf node. Okay. So if I have some data, and if I have yes and no values, so here I am going to get the yes and no values. Okay. So in that way, a path from root to leaf. Okay, a path from root to leaf. That means from here to here. This represents a classification rule. Okay, so decision tree works on the basis of classification rules. We are going to get the number of classification rules. So number of leads, leaf nodes that we have, number of classification rules we are going to get. So if a process to be yes, what it has to go through. Okay, if a process to it should be no, what a process should be going through. So what are the different factors we have that we are going to look into? So a decision tree consists of three types of nodes that we have already seen. One is root node, branch node, and leaf node. Okay, leaf node is nothing but the terminal node that we have. And what about the decision making tool here? Okay, when we consider all these different nodes, the decision making node we can see here is the leaf node. There we can see the decision. Okay, in one way we can say that decision tree is a decision making tool. Okay, what is the final decision that we are going to find? So we have decision tree algorithm that falls under category of supervised learning algorithms. So it contains a root node, a decision node, and leaf node. Okay, so it is also the decision node is also known as the stem node here. And it works for both continuous data as well as the categorical output variables that we have to do. So I have taken few examples where in case of oil and gas industry, so we are using the decision tree here. For example, we are trying to find out this solids handling. Okay, when in case of solids handling, in case of drilling process, it is a process where it is in the process that comes in upstream oil and gas industry. So we have upstream, midstream, and downstream processes in oil and gas processing. So in case of upstream processing, we get a technique. We get a technique to see that is solids handling. So what do we have here? We start with, okay, we take a root node here. So we take a root node here. Based on the root node, we try to find the decisions. What is there here? Do you know sand prediction? Okay, if I know the sand prediction, if that is yes, okay, then what is your answer? If no, we have to sample flow stream and we have to do the physical analysis. That is the only way. Okay, so this will be one classification tool here. And what if is yes? If I know what is the sand production is there, what I have to do? I have to remove the sand upstream of choke. Okay. So if yes, okay, if I have removed, if yes, the value will be wellhead desander. The same way, if the value is no, okay, if the value is no here, what will happen? Remove. I have to remove the sand before separate. Okay. If yes, in case of yes, what I will be having here, well stream desander. I am going to use the well stream desander technique here. If no again, we have to remove sand and separator. I am going to use cyclonic jetting is the process. So if again no, so what is happening here? The process will be continued. Okay. So I am going to use the final when I am getting the final node. Okay, this will be my root node here in this case. Use other means, any other means. Okay, that is the final in case of equation. So in this way, we can take the data, we can do our analysis. Okay, the final disposal we can see here. Okay, so when we get the final slurry, okay, when we do the dewatering process and we use the accumulator and all these things, we have to separate the sands, right? So we are doing the whole drilling process. There may be a chance of getting some sand particles and everything. So here we are looking into this separation process. Okay, this is something related to oil and gas industry. So to do this process to classify the whole thing, to know which method is best. Okay, and if I want to know the classification, if I want to next time, for example, if I get this method, okay, directly if I get this method, okay, and if I get this method directly, I can decide that we can use the accumulator here. After accumulator, I am going to get the slurry. So which method I am going to use? Okay, these analysis that we can classify. We can classify these methods based on the data decision. Okay, this one use case that I have taken to explain these different data. So in the same way, we can use the decision tree. Okay, we can use the decision tree framework for explaining the oil spill. Right. When it comes to the logistics, when we discuss about the logistics here, so oil will be transported in different ships. Okay. When there is any unforeseen incident that happens, what happens? This oil that is being taken through the ocean will be spilled. Okay, will be spilled in ocean, and that is a very hazardous condition. Okay, usually we see these conditions in Arctic offshore waters. Okay, the spills that are responsible, okay, respond because of that method. Okay, so here we are going to we are going to take the data and we will be trying to find out if we do the decision tree, what will be the processing. Okay, so we are going to take the marine oil spill data. Okay, from there we will be looking into the fuzzy sets. Okay, and in the same way, if I take a new oil spill cases, okay, what I am going to get the data. Okay, based on that I am going to build a regression model. Okay, I can build a decision tree. Okay, where I am going to take all these values. Based on that, I am going to look into the data. Okay, so in different cases, in different cases, we are going to use the decision tree model. So how do we build a decision tree here? Okay. So in case of building decision tree here, we can see here, I have a root, right? So this is the root node I have, and I can clearly see that these are my leaf nodes. And here I have a, sorry, these are my stem nodes, and here I have a leaf node. So this is my decision making. Okay, I'll be getting the decision here. So it uses the training data to build the model. Okay, decision tree model uses the training data to build the model, and there are three generator. Okay, that are very important. Okay, three things that are very important to take care of, such as which variable. Okay, which variable to split at a node, and what will be the value of the split. Okay, so that is very important. Okay, and decision to stop. Okay, which, like if I am saying this is the root, what is it about? If I have some data here, what I'm going to do here, I am going to take any of these values. Okay, I am going to take any of these values, and I am going to work on these values. Okay, so this will be my root node. Based on this root node, I am going to get the, based on the information that I have, I am going to divide this, and I am going to get, so how fast you are reaching to your leaf node, that is the matter. Okay, by using which root node, by using which column I can reach to my leaf node faster, that we are going to work in this process. So these 2 points are very important. Like which node you are going to which variable. Okay, in this case, which variable you are going to take as the root node, and how the split is going to be, and where the decision should be stopped. Okay, that is also very important point. Okay, what that about the terminal. Okay, it depends on the variable that we are taking. So assign a terminal node to a label. Okay, that is very important. Why? Because if I have a continuous data, I cannot work on it, because if I have a continuous data, so I cannot work on this process. So in case of decision tree, it is very important that the root node, okay, the values that we are taking here, that should be in the labeled format. Okay, that should be in categorical values. Okay, that is very important. So in the same way, decision tree regression. When it comes to decision tree regression, okay, when we are saying the decision tree classification, in the same way we have decision tree regression. That means my output variable. Okay, when I'm saying my output variable, this will be a continuous data. Usually in classification problems, my output will be a categorical data. So that is the major difference that we have here. But here in this case, we will be having a continuous data, continuous output here. So here we have something called as greedy algorithm. Okay, it is a basic algorithm that we are going to use in this process, where we will be looking into top-down approach and a divide and conquer method. That means the whole data will be divided. Okay, it will be divided in such a way that we will be getting the different nodes here. Okay, it could be a stem node, or it could be, so the final decision will be from the leaf. So it start all the training examples are the root values. So we are going to take, so we are going to do the experimentation here. Okay, so attributes are categorical. If continuous value, we are going to disguise them. Okay, that is something we have to remember. If we have the continuous values, we are going to discretize these values. So we have to start with discretization. So input data is partitioned recursively based on the selected attributes. Okay, so we'll be having the test attributes at each nodes are selected on the basis of the statistical measure, that is nothing but the information gain. So we get the information gain based on the entropy value. Okay, we get the information gain based on the entropy value, and we have the conditions for stopping partition. What are the different conditions here? If all samples for a given node belong to the same class, if there are no remaining attributes for further partitioning, okay, or majority voting is employed for classifying the leaf, okay, and if there are no samples left. In these conditions, we are stopping the partitioning. Because we are discussing about the huge data, not about not about the smaller data. What if we have a huge data, what is happening? So as we have discussed earlier, we have entropy and information gain values. So when it comes to entropy value, so entropy value is nothing but a disorder, okay, measure of disorder of impurity. So how much error we have here that we are going to calculate. So we will try to find the entropy of the output values of a set of training instances. And how are we going to measure it? If the output value entropy is 50 to 50 percentage, it is set as it is impure. Okay. Okay. And if the set is impure, okay, if the set is impure, we are going to say it as entropy is 1 by. And if the set is pure, we are going to set entropy is 0. Okay. So if output value split into 25 to 75%, the set is impure and the entropy value will be 0.8. So these are few standard values that we are looking at. Okay. And when it comes to information gain, the information gain is based on the decrease in entropy. Okay. If the error is less, okay, whichever root value, or it is a variable, whichever variable is giving me the least error. And if I'm getting in other case, whichever root value is giving me the higher information gain. Okay. So after a data set is split on an attribute, right, on a variable that we are speaking about. Okay. And constructing a decision tree is about finding the attributes that returns high information gain. Okay. So that is something we have to look at. So we have different formulas to find this. Okay. So here we can find here we are trying to find the information gain. So we are trying to get the information okay, the information value, okay, the information gain value from okay, different factors here. Based on that we are going to sum up. Okay, so the information needed. Okay, so first we start with expected information, that is nothing but the entropy. So how we are going to calculate the entropy? In the same way we'll be trying to calculate the information gain. So what are the different advantages of decision? So it is very important to know what are the advantages. Why do we use the decision tree? So when compared to other algorithms, decision trees requires less effort for data preparation during the pre-processing. So when it comes to pre-processing, but one data preparation that we have to do, if I do not have the data in format of categorical value, I have to convert the data. Okay, the continuous data should be discretized. Okay, that we have to do. And a decision tree does not require normalization of data. Yes, if I am taking all values in categorical, I need not to convert this data into normalized format. A decision tree does not require scaling of data as well. Missing values in data also do not affect the process. Okay. There are few things that are different. A decision tree model is very intuitive and easy to explain to technical terms. So finally, I'm going to get a tree. Based on the tree, I can explain what is happening, which classification zones are better. So in which cases I'm going to get this particular value. So there are a few disadvantages as we have pros and cons, okay, for every method. In case of decision tree also, I have some disadvantages. So what are the different disadvantages I have here? A small change in the data can cause a large change in the structure of the decision. Okay. So that is something we have to look into. Okay, so that may cause some instability in the tree that we are building. Okay, for a decision tree, sometimes calculation can go for more complex compared to other algorithms. Okay, so in case of a decision tree, often involves higher time to train the model, and decision tree training is relatively expensive as the complexity and time has taken are more. Okay, we are going to take all these values and we have to build it. So in case of decision tree, algorithm is inadequate for applying regression and predicting continuous values. And one more disadvantage is like, can say it as like, is always in case of the decision tree, they tend to have the uh, the fitting. Okay, overfitting is always a factor that we have to look into when it comes to decision tree. So when it comes to the use case, so there is something related to decision tree, how we have to, so what are the different factors we have and what we have to consider and all those things. And here I have some data. Okay, that data I have taken from drilling technique. Okay, there is a drilling technique that is called as hydraulic fracture drilling. So here I am trying to do the estimation of clusters per stage in oil and gas hydraulic fracture drilling technique using decision tree algorithm. So as I said earlier, we can opt. Okay, we can opt a decision tree for a classification models. Most of the decision tree models that we use that are used for the classification model. But in this case, but in this particular case, we can also use, as we have seen, decision tree regression is also possible. I am using the decision tree regression. Okay. So in this data, we can see we have different factors that are related to the well. Okay. Then first we will be understanding what is hydraulic fracturing. So this is some process that we have. Okay, has a proven technique to be a successful technique, I can say, for increasing the productivity of unconventional reservoirs. So to increase the productivity of these oil reservoirs, we are going to use the hydraulic fracturing technique. So the simulation design can greatly influence the well performance and impact the capital cost and economic returns. So to increase this, to increase the performance and impact, we are trying to do this study here. So the factor that I have considered here in this analysis, the clusters, okay, the clusters per stage, okay, it is the, so we can see here the data. So this is the factor that I have taken, okay, that will be my output variable. Okay, that will be my output variable and based on that I am going to work this data. So clusters per stage, when I have to explain this, it is defined as the number of perforations, okay, perforation guns used per fracture stage. Okay, when I'm saying perforation, when we do the drilling process, okay, so it is some part of drilling process. Okay, we will be using some perforation guns, and based on that, we'll be doing this drilling process. So in general, the average number of clusters used in the industry is in the range of 3 up to 8 clusters. A lower number of clusters per stage can better in achieving longer fracture networks. Since the hydraulic fracturing energy is limited to fewer entry points. Okay, this is something. This is completely a technical thing. Okay, but one thing we have to see here, like there is some standard here. Three. Okay, when we are looking into the clusters used in the industry, usually we can see 3 up to 8 clusters. So we can see some values like 9 to 15 also. So why what is happening in this data that I am trying to do. So when I'm saying that if it is a count data, I am taking it is a discrete data. So it's not a continuous data. I cannot say that this is a continuous data. This is a discrete data. Okay, where I am looking into the count of number of clusters. So here I am saying 9 clusters, 15 clusters. That is the data. So here I have something like the formation of reservoir name. Okay, And here I have the reservoir temperature. So we have taken the reservoir temperature here. Net pay. Okay, net pay is the how much feet we have went into, what is the diameter we have done, and what is the porosity. When it comes to porosity, it is something related to the rock material. Okay, the material that we have there. So water saturation level, whatever the oil saturation, gas saturation, all these values we have taken. So based on these values, I am trying to do the decision tree regression. So based on this data, I am trying to predict number of clusters. So I have used the heat map here for the EDA process. So I have used the heat map to find the correlation between this. So there is a lot of data here. Okay, there is a lot of data. Okay, we have seen only few data. So along with that, we have CO2 emission, H2S emission, nitrogen emission. So these are all possible when we are working on a oil field. Okay, and we have values such as oil gravity. Okay, stages, clusters per stage. Right. Okay, number of total propets we have. Okay, literal length. Okay, bottom perforation, all these values are very important to us. Okay, so these values we have taken, and now I am trying to find, is there any correlation with this? So I can, how can I find them? Here I have these values. Here I have taken the gradient value. The least value is minus 0.8 and the highest value is 0.8. Okay, if I have 0.8 value between two different variables I can say that there is a high correlation between these values. Okay, let us look into some data here and try to find some correlation. Maybe let us look into the cluster per stage only. I can see that if I take this value, maybe gas specific gravity. Okay, I can see that there is a correlation between my clusters per stage and gas specific gravity. In the same way, when I take CO2 values here, there is some correlation between CO2 and static wellhead temperature. Okay, in the same way, sand phase temperature also I can see that the correlation is more when it comes to CO2 values. And there is no correlation here. I can see that there is no correlation when it comes to H2S. Right? So these values you can see that there is no correlation. When it comes to stages, okay, number of stages we have, I can see that there is some correlation with the clusters here. Right? So I have done some data pre-processing here. Okay, based on the data what I have seen earlier, as I have taken the example, right, uncorrelated features H2S, right, there is no correlation at all. So these values I am not taking into my data, into my analysis. So I want to drop all these values. What I'm doing here, I have taken all these columns. I have saved the data in uncorrelated features, and so the data, okay, the data that I have is in the Wells data. So from this Wells data, I am trying to drop all these values. Okay. So now I have one value that is something related to reservoir, that I am trying to convert this data into label data. Okay. So now I have these values. Based on these values, I'm going to work on the analysis. So when it comes to splitting, right, I have to do the splitting here. I know my clusters of stages that we have. That is nothing but my output data. So based on that, so here we can see if this is my data. Okay, if I am saving my data in DF here. So except these values, okay, except the target feature is my cluster per stage. Okay, number of clusters per stage, that is my target feature here. Remaining all values except lease. I don't want to take lease value. It's a nominal data and that doesn't have any influence on my data. So I want to leave this particular column. So I am ignoring lease. Okay, I am ignoring lease and I am taking the remaining data. This will be my it's my independent data. Okay, when it comes to my dependent data, the target feature, I can see here, number of clusters per stage is my target feature. So here we have, so here we can say that I am saving my x and y values here. X value is nothing but my, so except the target feature, remaining all values are my input data, and only target feature, that is my output data. Okay, so I have done my data splitting here. So we can see the values. Okay, when I take the train and test data here, when I am looking into these data and when I have analyzed, I can see that the square errors here. Okay, so we can find out. We can use the different methods also for evaluation. So apart from decision tree, we can take these values. And here I have used, okay, here I have used the decision tree regressor. Okay, when it comes to regressor, I am going to look into the error values, right? So what about the error? What is happening here? Okay, that is something here I have seen. What is happening here? When I have train data, I can see that the max depth. Okay, here we can see that the max depth is something like 5 here, and for test data it is 10. And in case of train and test, when I have taken the minimum samples, okay, minimum samples leave here, I can see here clearly that the value is something around, almost I am getting the similar values here. Okay, train and test. So how we are taking these values? Okay, let me. So here I am creating a. If I want to get the scores, okay, I am looking for scores here. So I am creating, and the model that I have here is decision tree regressor I am taking, and based on this I am going to get my scores here. Okay, so I'm trying to find out the scores here. So finally, we have the decision tree. We can see the decision tree. Here, there is a root node based on the data, based on the different variables I have. So here we have taken the gas specific gravity. I have one attribute, that is gas specific gravity. So I can see the information gain value. Okay, I have taken the value here. Okay, these samples here, the square error here. Okay, yeah, I have taken the square error, all these values. Based on this data, I can see that how my data is getting split here. Okay, so these are different. Okay, now I want to know the. Uh, so this is one classification rule, right? This will be one classification rule, and this will be one classification rule. So how many leaf nodes I have here? That is very important. Okay. So if these are my leaf nodes, how many rows I have? So 1, 2, 3, 4, 5, 6, and 7 and 8. I can see that there are 8 different rows I have here. Based on this, I have tried to classify the data. Okay, so the easy way to classify the data. Okay, I'm looking into factor how I can classify the data. So we can work out based on the different attributes, and we can see that which attribute is giving me the less number of classification rows. Okay, that I am going to take. Okay, so this is something related to decision tree. Let us look the same data. Let us look into the code here. We have, so when it comes to code, so I have taken this particular code in Google Colab. Okay. Okay, so we are working on hydraulic fracturing, right? Hydraulic fracturing is the technique that we have. In the technique, we have some data. Okay, so based on the data, we are trying to look into the drilling process. This is completely related to the drilling process. Okay, so here, so there are many parameters that will be available, such as we have the number of propens we have propent type and size, okay, fluid design, stage length, okay, cluster spaces. All these are very important when it comes to hydraulic fracture. Based on that, we are trying to find some values here. In the same way, we can see here the hydraulic fracturing. So we the cluster design and well spacing is also very important. So we have looked into factors, okay. Like the spacing between the clusters can vary from 25 to 100 feet here. So how the process happens here, that is also very important. These factors we have to take into consideration. So different wells will be formed and we are going to get the well data. Okay. So I have imported all necessary modules that are required like NumPy, Pandas, okay, Seaborn, Matplotlib, okay, SkyFi. Okay, we have sci-fi. All these different modules are I have imported. The same way, scalar, we are doing some pre-processing here. So something like I am using label encoder here, and uh, for model, okay, for the machine learning model, the module I am using here is that nothing but the decision tree regression. And to find the scores, okay, to the mean squared error or to find the scores, I am using this technique. So what are the different values I have? So these are the different values I have. Okay. So this is my data. So I have uploaded my data. Okay. I have uploaded my data. I have taken the data directly from my GitHub repository. Okay. So I have given the link and I have taken the data directly. Now, if I see, okay, now if I see the description part, let us look into our output value. So what I can see here, the mean value, okay, let us look into the maximum and minimum values. Okay, when it comes to cluster stages, the maximum values are 15 and the minimum values I can see it as 7. Okay, sorry, the minimum value I have something 3 here. Okay, the minimum value is 3, the maximum value is 15. So as per the norms or as per the technical aspects, we can take something like 3 to 8, but here we have taken up to 15 clusters per stage. Okay, that also we have to look into. And we can see that there are the oil saturation values we have. Okay, when it comes to gas saturation, we can see that the maximum value is 0.81 and the minimum value is 0. So these are a few important factors that we have. And when it comes to diameter, we can see mostly the minimum value and maximum value is almost same. Okay, but the values changes. Okay, when it comes to water saturation, we can see the maximum value is 0.47 and the minimum value is 0.18. Okay. So the difference between mean and the range values also we can notice here, standard deviation values. Okay, all these different data we can take. And when it comes to Fahrenheit, okay, reservoir temperature, we can see the maximum temperature is 379 and the minimum temperature is 115 here. Okay, so these are the factors that are very important. And we have something like net pay here. That means the total depth that we are looking into about the well data. Okay, this is something related to well data here. The maximum depth I can see is 268 feet, and the minimum I can see is 56 feet. So these are some technical aspects that are very important when we look into the oil and gas fields. So here we have the data. Okay, here I am trying to sort these values. Okay, based on these values, I am just trying to look into. So I'm just taking top 10 values, right? So these are the least data I have, and these are the clusters I have. So I'm just sorting these values based on my number of clusters. So here I'm trying to find the heat map. Okay, the heat map that I have showed you earlier. Okay, these are the values that I have, and I am trying to look into the heat map. Based on this heat map, what I'm trying to do, I am trying to find out what are the values that are correlated to each other. Okay, and if there is no correlation between these values are not important to me. Based on that, what I'm trying to find here, I am trying to remove these values. Okay, I'm trying to drop these values. Okay, so the criteria, the basic criteria, the R value, right? I am trying to find the coefficient value, right? Correlation coefficient value, and I am having a criterion. If the criterion is less than this particular value, that should be removed. Okay, so based on that criterion, also we can remove these values. So here we can find out the value. Okay, here we can get these values. If I find all these correlation values, I'm going to get the correlation between different. Okay, what I'm trying to do, I am trying to remove these values that have very less correlation between this. So this will be my data. Okay, this will be my data after removal of the uncorrelated variables that are present in my data set. And here I have some data. Okay, here I have formation or reservoir data. That data is categorical format. I want to convert that data into numerical values. Here I am opting for label encoder. Okay, here I am using label encoder. And we have the cluster per stages. Okay, so this is my, as I said, my input and output variables. I am considering the number of cluster per stages as my output variable. Remaining all will be my independent data. And in case of the data, okay, here I am trying to, so based on my test and train data, based on my test and data, I have applied my decision tree regressor here, and I am trying to calculate the train score and test score. So how I am going to do it? Based on the mean value. I am going to take the mean value of the train score and the mean value of the test score. Okay. So based on that values, I am trying to find the mean squared error value. So I am trying to find the error. I am trying to compare the error between these values. So okay, if I take this data, if I upload this data, so I have the data. Okay, I have uploaded the data now. If I run this program, okay, so I will be running this program. Right. If I look into these values, okay, if I write like train underscore score, if I want to look what is the score values, okay. Okay, I have given this value in the definition. So I have created a scores here. So directly I'm going to get the values here. Okay, I haven't taken separately here. Okay, this value is separately. Already this value has been taken. Okay, so I am taking directly. Okay, I am creating a user defined function here, that is course here. Okay, directly I am taking the function here. Based on that function, I want to plot it again. Okay, so I have plot the values. Okay, I have taken different parameter ranges here. Okay, and using these parameter ranges, and I have used the parameter that is max depth. And I am looking into min sample leaf. Okay, these are different hyper parameters that we have. Okay, hyper tuning parameters that we have. Based on that, I am trying to find. Okay, so based on that, I can see that what are the changes I am having. Okay, if I am using max depth, so the values are in this way. Okay, if my train value is 10, I can see that my test value is something. Okay, my test value is 10, my train value is 6. So we have to have the less error value, right? So my error value when compared to train value, test value, these are very near. Okay, in the same way, we can see that my train and test errors, I can see that uh, when I take the train data, it is almost 10, and when it comes to test data, it is almost 10. So maybe if I take the minimum sample base, I can see that I can reduce my error score. Right? So that I can do. So here we can see clearly we can see it. So I have taken. I'm just presenting the decision tree here. You can see the decision tree. I have so here we have the value. So the root value that has been taken based on my information gain value, and here I am taking gas specific gravity is the value. Okay, based on the data. Based on the data, we can see here. So this is the split. Okay, this is split. I can see the data. So here finally we are trying to find out, okay, based on gas specific gravity, okay, that is the main group that we have taken, and bottom perforation and net weight. We have taken these three values here, and based on these three values, I am trying to find, okay, I am trying to find this range here. So what we have given here, so this data. So that will be my final output. Okay, final output I can see here. So in this graph, if I look into this visualization, okay, I can see that the net pay is 130 feet. At 130 feet, when I'm saying the gas specific gravity, I have taken gas specific gravity. It is defined as the ratio of the density of the gas of to the density of air. The density of gas and the density of air at 1 atmospheric pressure at 60 degree Fahrenheit. So these are few conditions that we have here. If ideal gas law, okay, if we follow the ideal gas law behavior, it is assumed that gas specific gravity is the molecular weight of the gas divided by the molecule. So the gas specific weight is very important when we are calculating the gas density. Right? When we are trying to find the density of the gas, and gas specific gravity is easy to measure at the wellhead. Okay, we are taking the wellhead and is used to indicate it is an indication of the composition of the gas. When we are looking into the gas composition, okay, in case of well, okay, we will be having the natural gas as well as the crude oil here, okay, and the specific gravity of natural gas ranges from about 0.55 to 0.87. These are some standard values that we have. And due to variation in the natural gas composition with richer gases, typically having higher specific gravity is also possible. And when it comes to perforation, okay, we have taken the perforation data, okay, bottom perforation, okay. So a perforation in the context of oil wells refers to a hole punched into the casing or line, so creating a channel between the pay zone, okay, creating a channel between the pay zone and the well bore to cause oil and gas to flow to the well bore easily. So we are taking the net pay, bottom perforation, and gas specific gravity, and I can see that net pay is 130. I am trying to find these values. Okay, so we have taken like 0.6 to 0.1 value. Okay, like the standard values are 0.55 to 0.87. So these are different analysis that we can perform based on this. We have taken the decision tree, okay, decision tree regression. Okay, friends, thank you for the session. Tomorrow, let us see the simple linear regression. Okay, simple linear regression program. Okay, module, and this is in relation with oil and gas analytics. Thank you, friends. Thank you for the day.